Hello, welcome to this lecture series. Today, I'll be solving a problem on connected masses. In this problem, we have three masses that are connected, as shown on this diagram. We are given that this is a rough surface, and the coefficient of friction of the surface is given as 0.4, and we are required to determine the acceleration of the system. Now, because this is a system of connected masses, the acceleration will be the same. We take this orientation as the direction of our acceleration. Now, to solve this problem, we're going to break it down into three parts. Now, this part, because this object is suspended, it will have a weight. And I like to draw this arrow to show the weight of this object. So the weight of this object will act downward. The weight of this object, let's call it M1G. And the tension on this string, according to Newton's third law, the tension will act upward. Let me call this T1. Now, this is one part of the motion. This object M3 is also suspended, so it will have a weight. The weight of this object, let me call it M3G. Of course, it will also have a tension on this cord. Let me call this T2. Now, according to this direction of motion, it means that this mass M2 will move to this direction. This cord is the same thing as this cord, so the tension on the cord will be the same thing. So this direction is your T1, and this direction is your T2, because this cord and this cord are the same thing. Now, if we consider this mass M1, you have it this way. So it moves downward, M1G, and this is the tension, T1. Okay, so with this, the force balance for this is T. Since it moves downward, we have a T1, negative T1 plus M1G equals to M1A. And if we make the tension the subject here, so your T1 equals to, when you take it to the other side, M1G minus M1A. You can call this equation 1. Now, if you consider this other a suspended mass, you have it this way. That's for the M3. This is M2, M3G, and this is the tension, T2. Now, this is going up. So here you can have it as negative M3G plus T2 equals to M3A. Now, if we make T2 the subject, you can have it as M3G plus M3A. We can also call this equation 2. Now, if we consider the M2 on the horizontal platform, you have it like this. So we have, this is T1, and this is T2, and you have the mass. So since this is the orientation, the direction is to the left, it means that for this system, T1 minus T2, then the frictional part is the resistance. So minus frictional force, which is mu M2G. So this equals to M2A. So that's the equation 3. Now, to solve for our acceleration, we can substitute this equation 1 for T here, and equation 2 for T2 to get expression for acceleration. So for T1, I can write M1G minus M1A. That's here. For T2, I want to write this. So minus M2, M3, G minus M3A. Here now, minus the mu M2 G equals to M2A. Now, if you collect those with A to the other side and the other, you can have M1G minus mu M2G minus M3G equals to, you take this to the other side, you have M1A plus M2A plus M3A. Now, to factorize here, you have M1 minus mu M2 minus M3 all into G equals to M1 plus M2 plus M3 all into A. So that means your acceleration equals to M1 minus mu M2 minus M3 over M1 plus M2 plus M3 all multiplied by acceleration. So this is the expression for the acceleration. If we now put the values now to get the magnitude of the acceleration, we can now have, in place of your M1, you have 15 minus 0.4 multiplied by 4 minus 7. Then here you have 15 plus M2 is 4 plus M3 is 7. So all this together will give you acceleration equals to, then you multiply this, assuming the G as 10, approximately, this will give you 2.46 meter per second squared. So this is the value of the acceleration to the left. All right, so if you want to get the tension, maybe T1, so T1 equals to M1 into G minus A. So this is, M1 is 15 into 10 minus 4 points, 2.46. So if you do this, you have 15 multiplied by 7.54, and you have your T1, the first tension, 113.1 Newton. To get T2, you apply this equation 2, that's M3 into G plus A. And M3 is 7 into 10 plus 2.46. So you have 10 plus 2.46, 7 times 12.46. And that is 87.22 Newton. So this is the solution to the connected mass problem. I hope you enjoy this calculation. You can also subscribe to this channel for more interesting videos. Thank you.